The last topic we're going to look at in relation to covalently bonded compounds or molecules is something called intermolecular forces. An intermolecular force is a force of attraction between two different molecules. So I have to have at least two molecules to talk about an intermolecular force. So the first thing is an intermolecular force, or IMF, is weaker than an ionic or covalent bond. An ionic or covalent bond is sometimes referred to as an intramolecular force. That is, a force that holds two atoms together to form a molecule. So to think about the difference between these two, you can think about a plate of chocolate chip cookies. So if I have a plate of cookies, of chocolate chip cookies, I can pick up the plate and all the cookies will travel together. But it's really easy for me to take one cookie off. So the plate is acting like an intermolecular force. It's holding all the molecules together, in this case all the chocolate chip cookies, but it's pretty easy to grab one chocolate chip cookie. Now once I have that chocolate chip cookie, if I wanted to separate the chocolate chips from the cookies, I would have to do a lot more work. So that would be like your ionic or covalent bond. The cookies are baked, so the chocolate chips and the rest, the dough, is all bonded together to form one substance. So first of all, it takes a lot more effort to break it apart, but then also I'm actually breaking apart my cookie into two parts. Just as if I break an ionic or covalent bond, I'm taking my compound and breaking it back apart into atoms. So this is a very important difference. So the force of attraction between two different molecules is really, really weak. There are three basic types of intermolecular forces, IMFs. One of them is referred to as London dispersion or just dispersion forces. The second one is dipole-dipole interactions, and the third one is hydrogen bonding. And when we look at these, London dispersion forces are the weakest, and hydrogen bonds are the strongest. So this list is from weak to strong. So let's talk about dispersion forces first. Dispersion forces, or London dispersion forces, occur between non-polar molecules. So you really need to know about polarity of molecules before you can talk about the force of attraction between two molecules. So once I know my molecule is nonpolar, that means the force of attraction between two different molecules is dispersion. Dispersion forces are caused by electrons moving around in their electron cloud. So here's a molecule, here's a different molecule. In general, the electrons, we think of them as being evenly dispersed, but at some moment in time, since they're all moving around randomly, I might have more electrons over here than I have over here. So that means I have a slight positive end and a slight negative end. Likewise, in this other molecule, if these electrons are moving around and they're close to this one, temporarily, because this is slightly negative, this end becomes slightly positive as the electrons move away from the other electrons. So this does not last very long because the electrons continue to move. So this is sometimes called a temporary dipole. But it's a very weak force of attraction between molecules. These are most gases, like if you think of nitrogen gas, oxygen gas, carbon dioxide, nonpolar molecules. They have this very weak force of attraction between the two molecules. The next type of intermolecular force is called dipole-dipole interactions, and this occurs between polar molecules. So if I have two molecules that I know are polar, the force of attraction between them is called dipole-dipole. So basically what happens is the negative end of one molecule is attracted to the positive end of another molecule. So ICl, very similar to HCl, positive I is positive, Cl is negative. So I have this force of attraction between the slightly positive and slightly negative ends. Likewise, if they're next to each other, the slightly negative end of this molecule is attracted to the slightly positive end of that molecule. So this force of attraction is stronger than dispersion forces because this partial positive and partial negative is permanent. In nonpolar molecules, the partial positive and the partial negative is temporary. In nonpolar molecules, it's caused by movement of electrons. In polar molecules, we get this positive and negative because of the difference in electronegativity. So we have fewer electrons over here and more electrons over there because I is less electronegative than Cl. So that uneven distribution is always there. So that causes dipole-dipole interactions. The third type of intermolecular force is a special type called hydrogen bonding. So in order for two molecules to have hydrogen bonding between them, within a molecule there must be an OH, an NH, or an F to H bond. So the example I'm using here is water. So water, within one water molecule, there's an OH bond. So that means the intermolecular force between two different water molecules is going to be called hydrogen bonding. So what happens here is very similar to dipole-dipole. The positive end of water is attracted to the negative end of the next water molecule. So really what happens in hydrogen bonding is that instead of having things that are very slightly positive or negative, H to O, H to N, and H to F bonds are very polar. So when they make molecules, they make very polar molecules. So you end up with hydrogen bonding. So hydrogen bonding is the strongest type of intermolecular force, and that's what causes water to have such a high boiling point. Again, if you think about other gases, even ones that are polar, like HCl is a gas at room temperature. ICl would be a gas at room temperature, but H2O is a liquid at room temperature because of hydrogen bonding. And if you remember from biology, hydrogen bonding is also one of the forces that comes into play to give DNA the double helix structure. What holds those two halves together is hydrogen bonding between atoms on the two different strands of the DNA molecule.